6.2 Review Exponents Rules. So the first rule we are going to do is for multiply and addition. It's also called MA. So in monomial multiplication, we multiply coefficients and keep base and add the exponent. So if we apply this rule to solve this example, then we multiply the coefficient, which is 5 times 6, that is 30. We keep the base, so that is x. Base is that is underneath the exponent. And we are going to add the exponent, that is 3 plus 4, and is 30 x to the power 7, your answer. Next, we are going to apply the division rule. In monomial division, we divide coefficient, keep the base, and subtract the exponent. And if you want to solve this example with this definition, then 4 divided by 8 is going to be 1 over 2. And keep the base, that is x. And on top, you're going to subtract the power, so 6 minus 3. So your final answer is going to be x to the power 3 divided by 2. So if you notice here, I wrote here 1, but you don't have to write 1 if you're already writing x, because 1 times x would be just x. Now for number 3, you're going to fill in the blank for 0 exponent. For 0 exponent, anytime you find 0 on exponent, we're going to keep that coefficient, change the base to 1, and drop 0 exponent. So what do we have here is 4. So we will keep the coefficient because it doesn't have any exponent. If this also have an exponent 0, for example, if 4 to the power 0, we will keep it as 1. But we will write the 4 as it is. X to the power 0, we're going to make it 1, and there is no other exponent left. So the answer for this would be 4. Number 4, we are going to discuss about the negative exponent. We keep the coefficient, reciprocal base, and change the exponent to positive. So if we apply this rule to example 4a, we're going to keep the coefficient, that's going to be 9, so we keep it. And then we are going to reciprocal, so 1 over x to the power 2, and change the exponent to positive. So we're going to take the reciprocal of that, and we're going to change the negative into positive 2. And now you know that the 9 times 1 is 9, so we can just write this as 9 over x to the power 2, and that's going to be your answer. Example number 4b, that is similar one, but in this one you have the coefficient that is a fraction, 3 over 5, we'll keep it. Now the negative exponent is on the bottom, so in order to make it positive exponent, we're going to take its reciprocal or flip it. When we flip it, we take the base or keep the base, and we're going to change the exponent to positive. Okay, and the final answer is 3x to the power 5 over 5. The next one is monomial addition of like bases and exponent. So if you have like bases and like exponent, then you can add the coefficient. So the coefficient of this term is 3, coefficient of this term is 6. We can add these two as long as we have same variable, as long as we have same exponent. So in this case we can, because we have same variable and we have same exponent, but we will keep the exponent as it is. We are not going to add that. We are only going to add the coefficient at this point. Now we are going to do these problem and simplify these problems. These problems, if you do them, it's going to really help you to do well in the test. So question number 1 is 9x to the power 0. So as we know, we keep the coefficient, and x to the power 0 is 1 because this is 0 exponent, and the answer is 9. For number 2 that has a negative exponent, if you have a negative exponent and you want to make it positive, you're going to take its reciprocal, keep the base, and turn or change the exponent into positive. For number 3, you're going to add the coefficient and keep the base, keep the power. Keep the base, keep the exponent. For number 4, you're going to do step by step. So first you're going to divide 12 by 15. So 12 and 15, they both go by 3. So 4 and 5. So 4 over 5. X to the power 2. And here you have x to the power 1. So 2 minus 1. Y to the power 4 minus 2. And then the final answer is 4 over 5, x to the power 1, y to the power 2. Whenever you have x to the power 1, you don't have to write the 1 on the top. So in this case, you don't have to write 1 on the top of x. For number 5, you're going to subtract these two terms. You just have to make sure that the two terms are like terms. And you can see that this is the same variable and same exponent. So it means these are two like terms. So 4 minus 3 would be negative 3, and you keep the exponent and variable as it is. For number 6, you're going to multiply the coefficient. So multiply 6 and 3, that is 18. And for the variable, you apply the rule when you multiply same bases, x to the power 3 and x to the power 4. Then you're going to add the power. Same bases, add the power. So the final answer is 18x to the power 7, y to the power 3. For number 7, add the coefficient, so 2 plus 7, 9. And keep the variable and its exponent as it is. Now we know that a to the power 0 or anything to the power 0 is always 1. So 9 times 1 is 9. For number 8, you have a power outside that you're going to distribute with each and every term on the number that is inside. So that's going to be 8 to the power 2, w to the power 4 times 2, that's 8. V to the power 5 times 2, that's 10. So the final answer is 64, w to the power 8, and v to the power 10. For number 19, you keep the coefficient same, so that's 15. And you also keep the y to the power 3 same because it's positive. All you have to do is to make the exponent negative 7 to positive 7 by getting its reciprocal. So you get this reciprocal, x to the power 7, and change the negative into positive. So the next one is distribute the power inside. So that's become 7 to the power 8, x to the power 8, divided by 7 to the power 10, x to the power 10. When we divide or use the quotient property, then we're going to subtract the powers if the bases are same. So in this case, that's going to be 7 to the power 8 minus 10, x to the power 8 minus 10. So what you get here is 7 to the power negative 2 and x to the power negative 2. We are going to take its reciprocal and change the exponent into positive. So your final answer is going to be 1 over 49 x squared, because 7 squared is 49. So I just took the square because it's not big term. So that's your answer. Question number 11, you're going to distribute the exponent to each term, each number inside. So this exponent will be distributed to 4 as 4 square, and this one is x square. This becomes 5 square. 4 square is 16, 5 square is 25. The answer is 16 over 25 x square. For number 12, you can combine these two terms because they are like terms, same variable and same exponent. So 4 plus 3 is 7, but you cannot combine 2x squared with anything, so you keep it as it is. Question number 17. If you notice I will consider this whole term as one term because you have a bracket around it and you have an exponent 0. If anything, doesn't matter what the base is. So the base is, in this case, this whole bracket. So base can be anything, but if the exponent is 0, it's going to be 1 as your answer. Now we are going to do number 14. Multiply the coefficient, that is 3 times 4, 12. Then combine the like terms. When you multiply two terms with the same basis, then you're going to add the power. So here the power is 1 and negative 3. So that's going to be 1 minus 3. And to the power negative 2 plus 4. So that's going to be 12. M to the power negative 2. N to the power 2. And you keep the 12 on the top, n squared on the top. And since m to the power negative 2, it has a negative exponent, so you have to take a reciprocal and change the negative into positive. So reciprocal, that is m, and change the negative 2 as positive 2. Next is you're going to flip this or take a reciprocal because negative exponent, and change negative exponent to positive exponent. Now distribute the exponent to 6. So 6 to the power 2, x to the power 10, y to the power 6. 6 to the power 2 becomes 36, 1 over 36 x to the power 10, y to the power 6. If you have a negative exponent on the top and on the bottom, then you have to flip that. To make a negative exponent into positive, you take a reciprocal of this, so that becomes n to the power 7. Take a reciprocal of negative 8, and it becomes m to the power 8 on the bottom.